It can't be right, it isn't fair. I brushed my teeth and combed my hair, but did it get me anywhere? I got a cold for Christmas.
That was I Got a Cold for Christmas by the Three Stooges. Hopefully you love the Three Stooges. Maybe you've never heard of them. Interesting fact, they're actually Jewish. But okay, they got into the holiday spirit of infectious diseases, so yay. Okay. Of course, there's a weekly assignment so look at that. And this has to do with your project, your research project. So your bacterial organism causes many symptoms. Choose one and describe what's going on in that host microbe interaction that causes that symptom. Okay? All right. Okay, so this is what we're going to finish hopefully today. We'll see how it goes. And I just wanted to pick up a little bit of information that we didn't finish last time. With all of the questions and quiz questions, I ran out of time. But it has to do with vaccines. It has to do with what happens when the immune system messes up. So here's a little cartoon. This is after clearing the body of an invading organism. The B cell retains memory in its target and rests until another infection occurs. So I thought this was rather cute. So he's getting the cytokine signal, and the memory cell wakes up and divides very quickly, becomes a whole bunch of plasma cells, and then they secrete antibodies and they take it out. So now if the Three Stooges had enough memory, maybe they wouldn't have gotten severe cold symptoms. Well, or maybe they would have. The colds are tricky. More about that later. Okay, so let's wrap up the vaccines. Okay, final words. So there's a lot of controversy about vaccines. You've been learning all about that. And for people who again say, well, maybe we should let nature take its course. Well, once again, here is just the chart to remind you that it is a powerful and life-saving tool. And there are a lot of infectious diseases that we don't see anymore. We tend to not think about them because we don't see them. A few things have been eliminated by vaccines, so you don't even have to worry about them anymore. Remember smallpox? Yeah, that's an awful vaccine, but we don't have to worry about it anymore. One of the things I should have mentioned too with the chickenpox vaccine, the reason people my age really need to go out and get that shingles booster is because, well, in the old days, everybody had a natural infection, and lots of grandkids would run around sneezing and coughing, and they would sneeze and cough chickenpox virus particles. Okay, and you get natural boosters that way. But since we're vaccinating all the little children, the adults are not getting natural boosters. So, yeah, so then they get into trouble and they have problems like shingles, which is something I can't address in this week's lecture, but I will next week. So hold on for that. So, one last thing, and I know this is like, yikes, but understand a lot of you are going to be facing a lot of fear out there. And I once heard a quote that fear just, I can make somebody afraid within seconds. Actually, car dealers do this all the time. Oh yeah, there was this couple here from Lincoln, and yeah, I think they went out for dinner, and I think they're gonna come back and snatch this little beauty up. So yeah, salespeople use this all the time, this tactic. It's very hard to override that fear. And of course, education is how we do that in many different forms. That education can take many, many years, and it requires a lot of patience. A lot of people, they understand rhetoric, again, salespeople, politicians, what have you, and understand that, okay, this is going to scare you, or it should. Do you even see the smallpox is dead? Right? So where do we turn for information? I'll tell you what, there are a lot of places out there you can get information like Health Freedom USA. You will start off reading the information from this website, and you'll say, yeah, this makes sense. Okay, yeah, this is good, this is correct, and they'll even cite from the CDC. And then something goes terribly wrong and they go south, and you wonder, okay, where do they get this information? So stay away from these organizations, the .coms. I'm not really crazy about the information that the pharmaceutical companies put out because, again, they have a financial sort, sort of a link to this. So, yeah, they're not going to be very objective. The government, FDA, federal, or the Food and Drug Administration, or the Centers of Disease Control, CDC, well, they're not bad, but they sometimes are underfunded. So, the information is good. The World Health Organization has the same problem. They have good information, but sometimes they're underfunded. But I do like the University of Pennsylvania Center for Bioethics, Ethics of Vaccines Project. You can read this when you want in your spare time. I just wanted to let you know that they understand that there are problems with vaccines and they stress this, but they see vaccines as an underperforming asset, but that government agencies, they need to oversee how these vaccines are manufactured and be very careful about this. So they understand we have to have this. This is very important, but let's be careful. Well, let's talk about measuring immunocompetence in you and in your patient. You know that when you first got into nursing school, you had to go to the doctor or maybe an employee health department and you had to get your blood drawn, and they were checking for your immunocompetence. They were looking for antibodies. Now, that's just one way to measure and look for immunocompetence, and we'll go into that for just a moment. But what does your immunocompetence rely upon? So, what is going to make you good at fighting off an infectious agent? Well, first of all, to define immunocompetence, that's how well you respond to an invader. Whether it's natural, somebody sneezed on you, or you ingested some food that that had some pathogens in there, or maybe it's artificial through a vaccine. Okay. This is going to depend on a lot of different things. It's going to depend on, do you have the correct receptors made? Okay. Can you make the memory cells? Can you make enough of them? Can you make the right ones? And when they're triggered, oh, are they going to become plasma cells that are going to make the right kind of antibodies to go after that particular pathogen? Okay, and most of this comes right down to genes. So if you have the genes, okay, you're going to be better at responding to the invaders, recognizing them as foreign, not self, with your receptors, and responding with antibodies, that sort of thing. Now, also your overall health, you have to feed, of course, the B cells and the T cells and the macrophages and all of those soldiers. You have to feed them. So your overall health is so very important. This is going to include, of course, then nutrition. So how do we measure immunocompetence? We can't measure everything. Sometimes a patient comes in and they have a lot of what are called opportunistic infections. So this means that they have a disease caused by an organism that normally doesn't cause disease. People have them and come into contact with them all the time, but they never get sick. But these organisms, if they encounter someone very ill, not very immunocompetent, these organisms will cause disease. So that's one way of measuring immunocompetency. But how about in the laboratory? So for example, when you had your blood drawn and they wanted to see, okay, well, do you have some kind of antibody response to, the things that we give you vaccines for? Okay. So, what they look for is an antibody titer in the serum. Titer is just the amount of antibodies that you produce. And the more you are exposed to a particular pathogen, the more memory cells you make, and then they're going to make more and more antibodies. You're going to have more antibodies in the serum. So, with a lot of exposure, as long as you're genetically apt to handle it, you're going to have a high titer in the serum. So if you had a vaccine for chickenpox and you have a good high titer, all right, then you're probably going to be immunocompetent. So one way that they look for this is they have a test like the test on the side. This is what's called an agglutination test. They will add what happens in the laboratories, they will take your serum and they will add antibodies to, or excuse me, antigens to the antibodies in your serum. So that means you would make an antibody antigen complex and everything would just agglutinate or chunk up. And you saw something like this when you took anatomy or physiology and they did a blood test on you. So you're, in this case, the blood cells were antigens and then they would add antibodies. But when you're going in and you're going into the public health department, well, then they are looking for particular antibodies in your blood serum. Okay. This is another way to look at it. So they're trying to, the antibodies would be something that you have in your serum, and they would just add something like chickenpox antigen. And if you have the antibody to chickenpox, then they will form these clumps, and you are immunocompetent because you will see agglutination appearing. All right. So, if you have a needle stick, do you make enough antibodies right away to cover you if you were exposed to hepatitis viruses in that needle stick? The answer to that is no, it takes a while. Remember, it takes a long time before you make enough you make enough antibodies, especially the IgG antibodies. Those are the first in. Takes a while. So this is called serum conversion. So if I looked in your serum to see, well, does she have or he have some antibodies that would attach to bits and pieces of a hepatitis virus? Okay, I know this is whole cell, but it's an antigen. All right. We wouldn't be able to tell, okay, because you wouldn't have enough antibodies for a while. So we'd have to wait for serum conversion. We'd have to wait for a few weeks. And then we'd take your serum and then we'd add your serum antibodies. And hopefully you'd have some antibodies in your serum that would attach to the hepatitis antigen, and we get clumping and agglutination. So if you have a serum conversion, this says that you have been exposed. It doesn't mean that you're immune, but it does mean that you're exposed. You have the antibodies in your bloodstream. You have seen your body has seen this non-self antigen, and you have generated antibodies, but it takes a little while. Okay. So serum is measuring the amount. Oh, excuse me, the titer is measuring the amount in the serum. But again, it takes a while. So first you get serum conversion, then you measure the titer. How high is it? If you have some agglutination but not enough, it means, okay, well, your titer isn't high enough. You did get serum conversion, but not a high enough titer. So they'd send you back, they'd give you a booster, and hopefully you'd make more memory cells and boost your titer. Okay. Someone who responds well to a natural antigen exposure or to an artificial vaccine and who makes good memory cells would be considered immunocompetent, immunodeficient, immunoconverted, immunoshielded, immunodesensitized. Of course. A, immunocompetent. Okay. Following a needle stick, it may take a few weeks before your body starts to make enough serum antibodies needed to detect hepatitis virus exposure. This is called serum conversion, serum sensitization, serum desensitization, serum flipping, serum titering. Serum conversion. You got to get the conversion over to making enough antibodies so that it's detected. Okay, how would we describe a patient with many, many antibodies against HIV? A, they have a high antibody titer. B, they have a serum converted. C, they have immunity to HIV. D, they have not serum converted yet. A and B are correct. Well, A and B are correct. Their serum has converted, and if they have many, many antibodies in their serum, then they have a high antibody titer. Okay, so the answer is E. Okay. Oh boy, look at this poor person. Clearly, this is someone who is allergic to a lot of things. So, we're going to look at what happens when the immune system messes up or the immune system disorders. And this is just one of those things we're going to talk about. So, immune system disorders, why are some people allergic to peanuts or penicillin? We'll address that. Why do people get autoimmune diseases? I'm going to try to address that. Why do some people never seem to get an infectious disease? Well, okay, I can try to address that as well. All right. So, scientists are still working on some of the answers as far as to answer some of these questions, which is why I'm going to do my best to try to answer them. What do we know? Well, we do know that, of course, it comes down to genetics, just like I mentioned before, and environment. So, okay, somehow genetically you are responding incorrectly to something, okay? And there might be things in the environment that trigger that, okay? How much is genetics? How much is environment? It depends, and we're still working on it. All right, so here is what we know so far. Immune system disorders. We're going to talk about three kinds. There's hypersensitivity. Hypersensitivity is the immune response that injures. Okay? Hypersensitivity is sensitivity to an allergen. Will Smith, you gotta love Will Smith. Normally, this is something harmless in the environment, but you overreacted. And poor guy, anaphylaxis there. So Will Smith with anaphylaxis. I love this movie. Love Will Smith. He's fantastic. Usually this is going to involve an IgE antibody response and also granulocytes. So we'll come back to that. Autoimmune diseases. This means that your immune system targets self thinking that it's non-self. So your own, all those things that you learned in the second and third response of defense response, the second and third lines of defense, sorry. Those are all going to go after your own body tissue. Wow. And then there's immunodeficiency. And as the name implies, this is a lack of an adequate immune response. Okay. Hypersensitivity. Here's my World War II bomber, and he is just going after tissue. Look at the inflammation. The redness, you can kind of see there's swelling, probably pain, a lot of irritation going on there. Okay. Hypersensitivities, this is very, very busy. Just take a breath, hold on. Okay, we're only going to look at type 1. In physiology, when you take that refresher, or if you have already, you'll probably go through 1, 2, and 3, or excuse me, 1, 2, 3, and 4. I'm going to briefly talk about 2, 3, and 4, but we don't really have time. You may certainly look over my notes, though, if that helps you in your future. Use this as a resource. So types 2, 3, and 4 are only for your information and will not be on a quiz, okay? But type 1, which is IgE mediated hypersensitivity, oh yeah, we're going to talk about that quite a lot. But notice, just looking at these pictures in type 2, oh my goodness, we have cytotoxic T cells and antibodies. And here we have a whole bunch of antibodies. It looks like they're making huge complexes. This might cause a problem. And here we have, again, we have our cytotoxic T cell and cytokines. And wow. So these are battles going on that shouldn't be going on. All right. But we will talk about the first one. This, again, you do not have to know, but this is a mnemonic that will help you if you do have to learn the 4 types of hypersensitivity. So here's a little mnemonic. It's acid. Type 1, type 2, type 3, and type 4. A for acid is allergic. Type 2, cytotoxic. 3 is immune complex. And the last one is delayed hypersensitivity. ACID. Okay? So maybe that'll help. Some of these do cross over just a little bit, but lupus, we're actually going to talk about this because this also goes into autoimmune disease. So there are some things that belong in autoimmune as well as just plain old hypersensitivity. So coming back to that. Okay, let's begin with A for allergy, okay? Remember, A is type 1 hypersensitivity, A for allergic. So this is going to be immediate, and it's going to have the IgE antibody involved. Okay, remember we said the IgE. What is special about IgE? Oh yeah, that's involved in allergies, type 1 hypersensitivity. Okay, allergies as well as parasites, right? Okay. So, the one thing about type 1 hypersensitivities or allergies, they occur faster than the others. Okay, the other threes take some time. In fact, it'll occur within 24 hours, but the most serious, life-threatening responses will occur within probably 30 minutes. Okay? All right. So as I said, this is going to have to do with the IgE antibody. And what it's going to do is it's going to, once made, it's going to attach to granulocytes and arm them and make them very reactive. So what that happens is that when the granulocytes do get activated with the help of IgEs, you get degranulation and inflammation. Remember our granulocytes over here? Yes, that illustration here, all the different kinds of blood cells. And again, a lot of these are involved in our defenses. So here are the granulocytes, eosinophils, basophils, neutrophils, and mast cells aren't listed there, but they are considered granulocytes, okay? So, little side note, maybe the body thinks it's a worm. Huh. Huh. Okay. So, what is the cause, you ask? Well, something in the environment, an allergen. Allergens generate allergies. Okay, so if you inhale something from the environment and it is an allergen, it could be pollen or pet dander or mold. I'm big on the mold. Yikes. If you ingest, ooh, okay, that could be peanuts or milk or seafood. And I know people who just, they ingest just just almost anything and they can break out in a reaction. So this can also include penicillin, okay, and antibiotics. What if it's injected? Yeah, so you can get like a venom injection from a bee sting or from a wasp, or again, drugs injection. Um, Genetics. We know that allergies run in families. We do know this. Okay, so let's talk about how this happens and again, it's some kind of interaction between our allergen, like cat dander, and our IgE antibodies and granulocytes. Now remember, granulocytes are packing chemical weapons, very harsh chemical weapons. When they degranulate, boom, okay? So somehow this innocent little piece of cat dander is going to trigger boom, but not the first time around. That's the thing about allergies. Usually the allergic reactions occur after a patient has already been exposed and sensitized. Not everybody gets sensitized with their first exposure or even the second, but some individuals genetically they do eventually become sensitized. Now, what is that? So your first exposure to the specific antigen makes you, again, think that, well, maybe this isn't so good, and maybe you're going to start producing antibodies. Okay? So this is sensitization, the first exposure. You really don't get much of a reaction the very first time. So you come in contact, it does induce an antibody response, but it's not a big deal. Now, the second exposure, that's a big deal. So you're not only going to have, some antibodies, you're going to have IgE antibodies, and they attach to granulocytes, okay? When they do that, so here they are all attached to the granulocytes, and this arms the granulocyte. So what is going to trigger it? If an allergen is present, that allergen will bind to the variable region, remember these sticky parts, and only to these sticky parts. And that will cause, okay, so here's our innocent little cat dander, and that's going to cause the granulocyte to just boom, okay? It's going to release all of the chemicals, and you're going to get all of those allergic reactions. Again, this can occur anywhere in the body, in the respiratory tract, in the GI tract, in deeper tissue even. Okay, so, and here again, I have cat dander attached to the IgEs and the degranulation. This, by the way, appeared in Nature. This was a great article. This is showing what might happen. Now, this is actually due to people were being tested for allergies, okay? And this is a localized allergic reaction. Very similar to hives. Now, hives, what is hives? A skin condition characterized by wheal and flare. What? Okay, it's a type of lesion. People get all kinds of skin conditions, okay? A wheal it looks almost like a blister, but it's not. It's pale, but then you get the red flare around, and that's what hives is. You get the wheal and flare. And like I said, you would see this in, say, a positive skin test for allergens. If you've ever gone through that, you know what I'm talking about. And I do know what you went through. Something like this, hives, a localized allergic reaction, you can block this with antihistamines. So stop the degranulation of the granulocytes. And an antihistamine does that. Hay fever, okay, well, this is going to be in the respiratory tract, and this will cause itching, teary eyes, sneezing, runny nose. And this all happened because you inhaled an allergen. Yeah, okay. Once again, blocked by antihistamine. Asthma. Okay, so this is going to go a little bit deeper. So here we have, this is, a specific kind of respiratory allergy. And there's a lot of chemicals going on in inflammation that are going to cause the following symptoms, including spasms in the bronchial tubes, mucus production. Okay. And in this particular case, antihistamines are not going to work. Okay, why? Because it's not just the degranulation and the histamines. There's more. You've got other chemical mediators in here, other cytokines, if you're like, speak English. Remember the cytokines during a battle. Okay, there's a lot of cytokines. They're going out and they're causing a lot of other things to happen. And some of those cytokines are telling other tissues to basically undergo changes, which causes the mucus production and the swelling of the airways. Okay, so an antihistamine isn't going to work. Corticosteroids, okay, hopefully those will work. Okay, so what triggers a type 1 hypersensitivity? Well, allergens, once again. What makes the best allergen or trigger? Proteins, right? Just like, remember, you have the strongest immunological response to a protein, which is why protein vaccines work the best. If you want to get a big inflammatory response and make a lot of memory cells, why, by golly, proteins are the best. The lipids, no, not really. Carbohydrates, nuh-uh. But unfortunately, that also means that proteins from your cat skin, proteins from shellfish, from nuts, okay, those are going to be good triggers. Bummer. Now, sometimes what happens is there's a chemical, an innocent chemical that enters your body, but because of the way that chemical compound is put together, it can grab onto a protein. And then what do you have? Okay, then you have an allergen. So, yeah, floating around your body. And I will show you how this happens. So, here we go. Let's talk about cat allergies. And again, this is from Nature Medicine. So, animal dander is loaded with potential allergens, proteins of all sorts. Up it goes. And again, you can get sort of that hay fever response. It hits the epithelial cells of your upper respiratory tract. Okay, itchy eye, itchy eye. And okay, the first time around, you can get away with it. You can play with that kitten the first time, but the second time, for whatever genetic reason, okay, you form the IgE antibodies, which loaded up the and basically armed the the granulocytes, and there you go. Okay. Penicillin allergies. Aren't you wondering why people can be allergic to penicillin and the beta-lactam drugs? Well, penicillin and the beta-lactam drug is not in itself a good allergen, but what it does is when it gets into the host, gets into you, it forms complexes with proteins and becomes an allergen. Ta-da. Okay, and it can cause more than just upper respiratory. Actually, it does. This can go systemic and get all the way through the tissues, causing asthma and even worse, like in my case. Okay, basically any allergen you can just insert here because this is what it does. Okay, so hypersensitivity 1 is allergen, okay, or allergies. So let's talk about a life-threatening allergy. A type of allergy that you could die from is called systemic anaphylaxis. Okay, not good. Again, this is IgE and granulocytes, but what happens is you get such a strong inflammatory response and allergic reaction that you get extensive blood dilation. Now, what would that do? Well, it wouldn't be good. Okay, you're going to lose blood loss, and with your blood vessels wide open, you're going to lose pressure, right? Go into shock. Yeah, that's not good. So, insufficient blood flow is anaphylactic shock. And yeah, on top of that, the bronchial tubes can constrict and you suffocate. Okay. Bee stings, peanuts, penicillin injections account for most cases, by the way. Very serious, which is, and by the way, you can get something like this from any injection, which is why you have to be careful with your vaccines. Okay, you don't want to go wandering off when you've had a vaccine, just in case. And like I said, the strongest reactions will occur within the first 30 minutes. So, okay, go get your vaccine at Hy-Vee and go sit in the restaurant, drink some coffee, check your email, or go shopping. But that way, make sure that the nurse practitioner or physician assistant is going to hang around a little bit. And there you go. Okay. So you're going to need probably epinephrine, an EpiPen, right? Which is adrenaline. And with that, vessels and muscles contract. So you get blood pressure going back up. Hopefully no shock. Cardiac output is increased and shock risk is decreased. So you just got to treat all these things with respect. People genetically, they're reacting very strongly to things that we've never seen before, like peanuts, right? Peanut proteins. In my day, it never happened. More on that later. So how do you treat? Well, again, it depends. If you've got hives, if you've got hay fever, okay, Benadryl. Use your antihistamine, but again, not for anaphylaxis, not for asthma. It reduces just the mild allergy symptoms of skin, eyes, and nose, not bronchial tubes, and it's going to stop granulocyte histamine release. Okay. Let's talk about corticosteroids. And again, people with severe allergies and asthma, or maybe they have an autoimmune disease. Sometimes they have to block their immune response with corticosteroids. So this does relax smooth muscle in the airways and it does reduce inflammation. So you've got, it's going to reduce all of those cytokines. So remember when you have a cytokine storm, that can kill you. But okay, so this depresses not only smooth muscles and all of that, but your eosinophils, your lymphocytes, your mast cells, basically your granulocytes, cytokine action, and dendritic cells. So, okay, all of this is being decreased in your inflammatory response. But okay, so what defenses do you have left? Not a lot, which is why we don't want to be on corticosteroids if we don't have to. And we sure don't want to do it for prolonged periods of time for even more reasons that I mentioned here. You don't want to be open to all kinds of infectious diseases. So corticosteroids, of course, you need to breathe. Let's not question that for a moment. Breathing is good, but sometimes though we have to figure out another approach. Okay, here's what some people do. They're undergoing allergy shots or what we call desensitization allergy treatment. Okay, so this is a treatment to prevent allergic reactions. Did you ever wonder how this works? Well, you're going to have patients who might ask you. So learn this not only for me, but for you, for your patient, for your family. Okay, maybe your children, unfortunately. So, what this is going to do is it's going to sort of alter your immune response a little bit, block it just a little bit by desensitizing yourself. Now, how are you going to do this? You're going to be able to do this by not letting the IgE antibodies have their way. Remember the IgE antibodies that are stuck on those granulocytes? Well, if we could just make a whole bunch of IgG antibodies, they would take out the possible allergen, block it, kind of neutralize it, and then the IgEs would be bored and they wouldn't be able to trigger the mast cells, right? Okay, so the IgG binds to the antigen that prevents IgE binding. So now you got to be very careful when patients are in the hospital or when they're in the clinic getting these shots. They can't go anywhere. They have to stick around for, just in case they get an anaphylactic reaction, right? So patients are injected with very dilute antigens over and over and over again to make a lot of the right kinds of memory B cells that will make the right kind of IgG antibodies. Now, you're still going to have the IgEs made, but okay, I'll show you what happens in just a minute. So these are low doses of the antigens. So, like I said, it's probably what we understand as IgG versus IgE. If you have enough IgGs, then the IgE are bored. No free IgE means mast cells don't degranulate. Okay, you're like, what? So here I have the mast cell. Let's say you've already been sensitized. So the IgE antibodies against the cat dander have already been made. Okay, you've already made the antibodies, but they're IgE. And they've already attached to all the granulocytes. And man, if one little piece of cat dander gets there, or a peanut, or penicillin, or a protein from shellfish, okay, that will arm the granulocyte and you'll have degranulation. But look at this. They're not the cat dander is not getting to the IgE antibody. Why? Because they're all bound up by all the newly formed IgG antibodies. The IgG antibodies that are now being made because you're undergoing desensitization allergy treatment. Okay? Okay, so again, you have your bored IgEs. They're bored. Okay. And you just have to make enough IgGs to block them. Okay. Now, there's other things that you can do to treat certain problems. You can make preformed antibodies that can actually work in very interesting ways as therapeutic agents. So sometimes patients are given a new drug and you wonder, what is this drug? And you're not quite sure. And sometimes they end in MAB. That stands for monoclonal antibodies. So the patient is getting antibodies. Why? Well, remember, antibodies are very specific, like heat-seeking missiles. They go after one thing and one thing only. Okay, so what could we do with that? So, okay, you can actually make antibodies to go after the other antibodies. So you can make not only, with the desensitization therapy, you can give somebody preformed antibodies, and that will clump up all the IgEs before they have a chance to get over and attach to the granulocyte. You don't need to know the name of this particular drug, but it ends in MAB. So whenever you see AB, you think antibody. It's not a chemical like a poison. No, no. These are antibodies. They're using something preformed, pre-made. Okay. This is how monoclonal antibodies are made. You don't need to know this very in much detail, but they take cancer cells actually, and they fuse them with, and the cancer cells are myeloma cells, the B cell line that are cancerous myeloma cells, and they fuse them with regular B cells that make a particular antibody. So you get these cancer cells, but they're not going to be cancerous. What they do, though, is they replicate indefinitely and they make tons and tons of antibodies. Now, because these antibodies are very specific, we can make antibodies that attach to, ooh, just about anything. Maybe a marker on a tumor cell. And we can attach a radioactive little chemical to it or some kind of toxin or something like that and release this into a patient, and it will bypass every other cell, but it will attach to tumor cells. It's very clever therapy. So on a test, just know if I say, okay, what is this drug that ends in MAB? You would say, well, these are preformed monoclonal antibodies, and these are used in therapy. Okay. Here are some examples. Some other examples of where antibodies are used in therapy. Have you heard of gamma globulin? Somebody gets a needle stick, they've been exposed to rabies, and they get gamma globulin. Well, what is that? Is that a poison? No. Is it an antiviral? No, 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 no. What this is these are preformed antibodies. So gamma globulin is also immune globulin, usually IgGs, usually. And they would be antibodies against something specific, like, oh, I don't know, antibodies against rabies. Okay. So we give these to patients to stop immediate threats because the patient slash host can't get the job done fast enough. They can't make their own antibodies fast enough because it takes several weeks and you don't want to mess around. So, but when you inject, okay, these preformed antibodies, so these would be antibodies against, and that would attach to rabies viruses actually, and neutralize them so they can't hurt the patient. Now, this isn't permanent. This is just temporary. It's a temporary fix. This does not mean you get some kind of memory. It's not a vaccine. These are preformed antibodies, so you didn't make them. They're temporary. Here's some others. Here is an immune globulin against the tetanus toxin, which will kill you very quickly. If you're not making your own antibodies, you're going to die. So they many times give you an immune globulin with anti-tetanus toxin antibodies to neutralize the tetanus toxin. They do this a lot also with botulism toxin and several others, Clostridium perfringens as well. So here we have if you needed antibodies against polio viruses, but again, we don't have to worry about it. And this would have, again, a different kind of antibody. So notice they all have, again, different types of variable regions. Okay, they would all neutralize different things. Okay, so I'm going to quickly go through type 2, 3, and 4. Type 2, hypersensitivity. Remember, A for allergy, C for cytotoxic acid. So this response destroys cells at cytotoxic hypersensitivity. It does involve antibodies as well. The antibodies will react with molecules, though, on a cell surface. And because of that, it's going to trigger the destruction of cells. Two ways that it does that: through the complement system. It actually will put that membrane attack complex and attach it to one of your cells and kablooey, blowing up your cells. This can happen because the natural killer cells start releasing perforin and granzymes, boo, blowing up your cells. And golly, if this happens in blood vessels, this could produce debris, block blood vessels, start clotting. You could get kidney damage, as well as fever, respiratory, digestive problems. It can be life threatening, which is why we need to be sure that we don't give the wrong blood group when giving a transfusion, because mixed up ABO blood types will do this and cause hemolytic disease, especially in a newborn. There's also, well, of course, when the fetus is Rh positive, that means they have an antigen on their blood cells. Mom's Rh negative, she doesn't have it. So when she is sensitized the first time with the first baby, she gets memory. But then if the second baby is also Rh positive, she doesn't recognize the positive and she thinks that's non-self. So, her immune system would go after the baby, which is why you have to give preformed antibodies, anti-ROGAM, right? Which is Rh antibodies, and that will bind to any Rh blood cells that have entered her circulation. That's kind of nice. Okay. Okay, so again, this is ABO hemolytic disease. By the way, incompatibility occurs in about 20 to 25% of pregnancies. And and hemolytic disease only occurs about 1 in 10 such infants. So you can look at this. I'm not really going to spend any time on this. I don't have time. How about type 3? This is going to be, okay, so ACI, acid immune complexes. This just means IgG and IgM antibodies started to attach and form big clumps of antibody antigen complexes. And can you imagine if that occurs in your joints or blood vessels? Yeah, it can actually trigger blood clotting. Okay, so this can happen because you've been exposed to pathogens, but also because of dust. So, and by the way, penicillin, a severe penicillin reaction will do this. I just wanted to show you this is a really bad case. This is disseminated intravascular coagulation, DIC. This can occur because, again, you've formed immune complexes. So you can get rashes, joint pains, pretty bad stuff. We'll talk about farmer's lung a little bit later on. I just don't have time, you guys. Sorry. So type 4, this has nothing to do with antibodies. This is all the cytotoxic T cells and sometimes natural killer cells going after your tissue. So this can occur anywhere in the body. The peak is usually 2 to 3 days following an antigen exposure. But actually, this is what happens when you get a tuberculin skin test. So you get the little pieces of Mycobacterium tuberculosis, the bacterium, and it's injected in the skin, and you get kind of a thickening and a reddening. More on that a little bit later on. I just can't spend any time on it. Okay, and of course you can get dermatitis because you can form basic your T cells in your tissue, your cytotoxic T cells and your natural killer cells don't like the bad jewelry you're wearing. So nickel jewelry and a lot of other things will cause contact hypersensitivity or contact dermatitis. So this would be me. Okay. And this is just showing more and more of what happens. So again, it's not an antibody thing. It's the T cells are going after your tissue, and you're having a big battle. Cytotoxic T cells with perforin and granzymes, and yeah, pretty bad. And this just shows you can get some really bad blistering. Here's the helper T cell that just freaks out. It gets exposed to something like nickel in your jewelry. And the dendritic cell says, here, T cell, you need to respond to that. And the T cell says, fine, I'll tell the cytotoxic T cell to go and blow up, attached to the cells here, and blow up. And this is what you get. So, yikes. All right, how about some questions? When your immune system responds to something harmless in the environment and actually causes harm, this is an immunodeficiency, immunocompetence, point of irreversibility, desensitization, sensitivity. Of course, E, hypersensitivity. Okay, so autoimmunity. This is sort of your body saying, hey, you got the wrong guy. So this is something that isn't even foreign. This is self. An autoimmune disease means that, okay, you're not overreacting to some foreign particle and thinking that it's bad when it's not. This is you reacting to you. You look weird. So you look for some odd reason like non-self, and there's a whole range of autoimmune diseases. By the way, ladies, you are 3 times more likely to have an autoimmune disease. Yeah, congratulations. I know, me too. I hate it. So, in fact, you're more likely to get most immuno problems. So, okay. So, as far as these autoimmune diseases, they can be organ specific. So, it can attack one organ like your pancreas or go systemic, which is bad. Okay, damage results from antibodies and or cell-mediated immune responses. So again, it's looking at your own cells going, let's attack. So in type 1 diabetes mellitus, this is organ specific. For whatever reason, your body thinks that the beta cells, the pancreas, are non-self. Okay? And your cytotoxic T cells go after it. Now, remember, the beta cells of your pancreas are the ones that produce insulin. Not good. So if these cells aren't around, you're not making insulin, and your cells of your body are no longer going to properly take up glucose. Remember, the insulin is like the key. It has to go into the lock before the cell takes in the glucose. So here we have an example of Graves' disease, and this gentleman has an inflammatory response, basically called a goiter. The antibodies are attacking receptors on the thyroid, and the thyroid, because it makes thyroid stimulating hormone, you get an increased activity actually. Okay, so lots and lots of hormone production and gland enlargement. And again, you can get the goiter. You don't need to know Graves' disease, but this is just one of those things. Do you know this actor? This is Marty Feldman. And yes, this is from Young Frankenstein, which is one of my favorite childhood memories. But Marty Feldman kind of had the bulging eyeballs. So he had Graves' disease. He had an overactive thyroid, too much hormone, because again they were attacking the receptors. So the inflammatory response was looking at cell receptors here and thinking, whatever this is, it's non-self, so bad. Okay, another autoimmune disease. Now this one you need to know. This is there's two of them you need to know. Systemic lupus erythematosus, also known as lupus. Some use the abbreviation SLE. This is systemic. Why? Okay, imagine, if you will, that you had an immune response against your own nuclei. Now, this young lady, okay, she's full of cells, and most of those cells have nuclei. So imagine getting a humoral response, making antibodies, and they're all labeling these cells for destruction, the cell nuclei. So this is going to be systemic, and she's probably going to suffer from severe joint pain, swelling all around in the joints, rashes, but one of the classic rashes is the butterfly rash here. Okay. Something else, my mother suffered from this, and it is in my family. So far, I'm okay. But rheumatoid arthritis is another example of an autoimmune disease, and it is systemic. Basically, it thinks the connective tissue is bad, foreign, and especially, again, in the joints, which is why you see swollen joints. The T cells and antibodies target all of this tissue. You get swelling. Just think of a constant battle going on all the time in your joints. And again, it can cause paralysis, so you can't use your hands, and it's very painful. Okay, this is another one which is very important. This is Guillain-Barré syndrome. Raise your hand if you've had a patient who's had Guillain-Barré. Somebody? Okay, well, what happens? The patient will come in and they might have anywhere from mild to severe paralysis. Okay, like this gentleman here. So what happens is the immune response goes after the myelin sheath that insulates your nerves. Nerves are kind of important. Okay. So, yeah, what happens if you don't have a myelin sheath for insulation? Well, okay, you're not going to get impulses, you're going to have paralysis. This is triggered by infectious organisms. So, like this gentleman may have suffered from some viral or bacterial infection. The immune system went after the bacteria and viruses and took them out, took care of them. But some viruses and bacteria will confuse the immune response. Some bacteria will look and have ID tags like what are on the surface of the myelin sheath. Or also some viruses will get into side cells and those cells will start looking like, ooh, the myelin sheath. So you get an infection, but it's gone. But the immune system gets confused. So, what kinds of organisms trigger these? Well, we know of a lot of them. Something called Campylobacter jejuni, very common if you consume unpasteurized foods. People who work in dairies and farms with cows and other animals get this. Sometimes it's just a GI infection, but it goes away, and the next thing you know, there's paralysis. Some of the herpes viruses, there's a lot of different kinds. There's herpes simplex, chickenpox, mono. Yeah, influenza. Something that sounds like influenza, which is Haemophilus influenza or H flu. Lots of others. Now, if the real infectious agent can trigger Guillain-Barré, could a vaccine that contains those bits and pieces or whole organisms trigger Guillain-Barré? Yeah, unfortunately. 1 in 100,000 recipients might have some effect. Again, anywhere from mild to severe. Okay? This tends to be more of a type 4 hypersensitivity, but I'm still putting it in here. Okay? So again, this is not really antibody motivated. This is your cytotoxic T lymphocytes going after the myelin sheath. So look, so the neuron's trying to send out signals, not working. Like on the right hand side, it's working. On the left hand side, it is. So, okay, you're not going to have any muscle action. So when your patients come in with Guillain-Barré, you're going to have to tell them, or you should be able to explain to them, okay, you had some infectious organism in your past. It went away, but your immune system got confused and thinks it's still fighting it. And that's what's going on. So I've met a couple people who have had this. Okay, and one was a young gentleman. He was about 24 when he got it, and he always had to walk with a cane afterwards. We think this happens again because of molecular mimicry. You don't need to know these terms, but again, we think that there are little ID tags on the outside of some of these organisms that look like the myelin sheath. Okay, that's what we think. Okay, by the way, multiple sclerosis is a lot like this, and if you have somebody with MS, there's a new drug that has just supposedly been approved, so look into this. You might be interested. I'm not going to have time. Immunodeficiency. This is when the body is yelling, "Help! Is there anybody out there? Can anybody respond to this?" So immunodeficiency, as the name implies, this is a lack of sufficient responses to something non-self. There are two ways to do this. There's the primary type of immunodeficiency. You're born with it, so it's congenital. Results from a genetic defect, or it could be also an environmental factor that impaired development. We think that might be it too. Second is you acquired it throughout your life, and it occurs as a result of infection or some other stresses on the symptom or on the system, excuse me. And this could be like malnutrition can cause immunodeficiencies. Stress can cause immunodeficiencies. If you had influenza, that can cause immunodeficiencies. And of course, if you have HIV, that definitely causes immunodeficiency. So all of those are secondary acquired, okay? So here's the worst case scenario, and there are many cases that are not this far, not this advanced, but what would happen if someone couldn't make good B and T cells, no humoral or cell-mediated immune response? Okay, think of all the things you couldn't take out. You couldn't take intracellular pathogens, right? Because without your cytotoxic T cells, yeah, they're not going to work. So you can't take care of intracellular pathogens or cancer either, for that matter. Um, You can't go after extracellular things very well either. So all the bacteria and viruses that are free floating, yeah, wouldn't be able to do it. And you sure wouldn't be able to make memory because you don't have your T cells. So this is severe combined immunodeficiency, or SID, also known as bubble boy syndrome, which is so tragic. And there are some people who cannot make good B cell responses, some can't make good T cell responses, some can't make good complement, some can't make natural killer cells. So there are many different intermediates that we just don't have time for. So, like I said, there are a lot of exposures throughout your life that can cause secondary immunodeficiency disorders. So, let's talk about viral infections that can do this. Measles. Thank goodness we have a measles, mumps, and rubella vaccine, but measles will replicate in lymphoid cells and destroy them. Okay. In addition to measles, and you don't need to know the following, but syphilis, leprosy, malaria, all are going to impact T cell populations and macrophage functions. So T cell mediated, right? Okay. So intracellular parasites, memory cells, that sort of thing. And macrophages, your garbage men aren't going to be working. They're going to be on strike. So that's not good. Okay. So HIV, we already know that. It destroys your helper T cell, your CD4s. So what are you going to do? Yeah, what do you have left? Well, okay, you have your B cell humoral line, but you can never make memory. And you can't go after intracellular bacteria, intracellular viruses, nor can you go after cancer. Okay? Okay, I want to address a few things. Therapy. So, how about an immune booster? Really? So you see this, you should ask, really, what kind? What if I have some hypersensitivity? What are what if I'm responding and I have an autoimmune disease? I don't want to boost anything. Okay, probably not. So, yeah, you better tell me what kind you're boosting my immune system. And again, what kind, even if it worked, do I want this? So little side note about this one, created by a school teacher, which cracks me up. She's never so wonder how many immunology classes she had while going and learning her K through 12 curriculum. But okay, just so you know, Airborne just lost a big lawsuit, 23.3 million. You should know that Airborne's creator is Victoria Knight McDowell, and she is a school teacher, and her husband, Ryder McDowell, and he's the script writer. So who else to push this? So instead of hiding their lack of credentials, they boast about them on their webpage. So yeah, I don't think so. How about this? And pay attention here. How about an immune modulator? Keep your balance. Keep stress levels down. High stress levels will really mess up your immune system. Okay? So what you don't want more of a particular response. You want the responses that you have to work properly, to respond properly. Do you remember the handshake and the chemical signals, right? That go on. You have your dendritic cell talking to a helper T cell, which then might have to talk to a B cell. Everybody has specific receptors. They're doing their handshake. They're having a specific cytokine conversation. So we want them to work well. We want an immune modulator. What would that be? Okay, so maybe you're not into yoga and meditation. If not, try vitamin D3. Vitamin D3 is amazing. If you look on, there's lots of blogs. You would think that vitamin D3 would give you world peace. Wouldn't that be nice? But here is an article if you want to read this. So D's the vitamin, and get D3. D3 is the bioavailable one. Don't just get D. Okay. But it regulates your T cells. Oh, yeah, intracellular parasites, cancer, viruses, and oh, yeah, tells the B cells to be more efficient and make memory. Okay, so where do we normally get vitamin D3? Or at least vitamin D. Do you remember? Nutrition? Sunlight. Yeah. So people normally get their vitamin Ds from sunlight. Okay. And we know vitamin D is a direct and indirect regulator of T cells. We know this. You can look it up. You can click on the link. By the way, here is a map that shows the global distribution of multiple sclerosis, a very nasty neurodegenerative disease, again, attributable to probably an autoimmune disease. So looky here, high risk right here. By the way, the equator is right here where you get the most sunlight. Okay. So, And by the way, in the United States, where do you think the highest number of cases will be found for multiple sclerosis and autoimmunity and other immune problems? Right here, Pacific Northwest. Okay, Pacific Northwest, which is okay, like Oregon, right? All those clouds and rain. Yeah, high cases of MS there. By the way, we could look at again a lot of immunodeficiencies and autoimmune diseases, same thing. And there's definitely some kind of trend going on here. So if you're getting enough sunlight, we tend not to see these autoimmune diseases. So that's why they push the D3, everybody. Okay, how else can you modulate your immune system? How about tryptophan and niacin? Tryptophan, I heard of that in nutrition. Oh yeah, tryptophan comes from turkey. Yeah, Turkey Day coming up. Niacin, vitamin B, one of the vitamin Bs, one of the good ones. Very good T and B cell modulators. Very good. By the way, so if you go out and get tryptophan, get the L-tryptophan, and also take it at night because it will put you to sleep. It'll make you sleepy. Little side note too, by the way. Don't take vitamin D late at night because it makes you awake, almost like sunlight makes you awake. So take your vitamin Ds throughout the day, maybe morning and afternoon, early afternoon at the latest, but not at night. Take your tryptophan at night. Okay. Tryptophan also helps you make serotonin. You know, the happy neurotransmitter. Yeah. So serotonin. So yay. So tryptophan is a win-win. Be careful though, too much tryptophan might mess up your normal microbiota in your gut. So be careful of how much you take. Okay. So just summing up, why do the bacteria make it and survive and cause disease and make us sick? What did they, and sometimes people don't get sick. So, between pathogens and hosts, it's all about, again, genetics, it's about nutrition, and also numbers. Okay, numbers. So when it comes to the pathogens, how many soldiers are coming in? What weapons are they packing? Well, that's going to have to do with genes. They could be carrying other virulence factors, again, genetically virulent, making toxins, that sort of thing. If they're fed well, and by the way, a lot of pathogens like to steal your iron. But anyway, if they're well fed, then they're going to have a good old time of it. So what keeps them out? Your barriers? Is your skin intact? Hopefully so. What about your numbers? Well, that would be your soldiers and weapons. The weapons are chemical weapons that have to be manufactured in the immune cells. So, are your immune cells made well? Are the chemical weapons made well? That all depends on your genes, right? Okay. And you want to feed them. You want well-fed, happy, healthy cells, your white blood cell soldiers. Get them enough oxygen, exercise, that sort of thing. Then they can make ATP. You want vitamins, good amino acids, and iron. So let's just summarize all the factors influencing your susceptibility to diseases. So immunocompetence, genetic constitution. There are just some people who get sick all the time and some people who never get sick. The result of your general health, nutrition, age, and behavior. Okay, so it's like everything else. Um, Exercise, eat right, be careful what you expose yourself to. Sadly, age sounds very ageist, but the truth of the matter is, ladies, and this is true for gentlemen too, we lose memory as we age. You're like, yeah, I know, cognitive memory. No, 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 not just cognitive memory. as as everything kind of breaks down, it turns out immunologically we lose memory cells. So we can then get disease where before we were pretty well protected because we had already made memory cells, but the memory goes away. So it's important for older people to get those boosters. Okay. So when it comes to general health, again, get enough iron. By the way, without iron, your T cells drop. So take iron, especially, after the menstrual cycle, after menses, you want to get some iron in there because you don't want your T cells to drop and reduce their function. Of course not. Do not smoke, right? Not only is that going to hurt your cilia that gets everything up, but yeah, the immune cells are all tied up clearing the blood and tar out of your lungs. So your poor dendritic cells. Sun. Now I know, didn't I just say the sun makes vitamin D? But uh, in moderation, unprotected exposure temporarily depresses T lymphocytes and natural killer cells. So yeah. So these are the guys that defend you not only against viruses but cancer. Hmm. Exercise increases lymphocyte activity. Yay, personal hygiene. Okay, keep it clean. Wipe from front to back. Okay, not only you, but your patient and your children. Okay, so and keep it clean. Reduce, reduce, reduce. Take care of your skin. Occupation. Well, unfortunately, all of you are on the front line, so you tend to be more exposed to pathogens and needle sticks and all kinds of things. So, sex, oh, sorry, laughter shouldn't have come up so soon, but yes, unfortunately, if you are female, we get a lot of problems. We tend not to be as immunocompetent because we have a short urethra, right? We get a lot of bladder infections and other things. Laughter, the evidence isn't in yet, but it can't hurt. There's some evidence that says yes, laughter increases your immunocompetence, then other studies that say that's not really true. But we do know that stress reduces your immune response. So seems like laughter is the opposite of stress, right? So minimize your stress. Stress causes many hormone changes and causes a lot of illness. But we know that it does, in fact, inhibit B and T and natural killer cell activity. So that's wiping out, your a lot of your second and third immune response. By the way, there was a study done that looked at people under chronic stress, chronic stressful situations. They were actually they looked at, excuse me, not pharmacy students, dental students, and caregivers of people with like Alzheimer's. The people that have to take care of their older parents and spouses, and they were the ones that had the most stress hormones. They found that their vaccine effectiveness was actually reduced 30%. So maybe you shouldn't go get a vaccine when you're under a lot of sustained stress. Okay. So, yay. Maybe, well, if you can help it. Okay. So, what is this about? Why is it that everybody, it's like everybody knows somebody with a severe allergy to something, like peanuts. You guys, really, when I was growing up, peanuts were everywhere, even movie theaters. I mean, it was part of our diet. And nut allergies were just unheard of. Most of these things were unheard of. So, why is this? I'm going to address something with you. And by the way, some of this information comes from The Guardian. Why are our little ones they've got all these respiratory tract infections? Now, we used to think it was air pollution, and LA and California had some of the most stringent control measures in place to control air pollution, which was great because pollutants in air can cause cancer and all kinds of other things. But it didn't reduce the number of asthma cases, okay, in the little kids. We just didn't see it decrease, and we thought we would. But then, of course, that's still good. We don't want lung cancer or anything. We want to be able to breathe. We want clean air, but this wasn't addressing it. So what do we think it is? So why do we have increasing rates of allergies and asthma? It just keeps going up. Going to talk to you about the hygiene hypothesis. Now, if you remember, a hypothesis is an educated guess, but it's not somebody just saying, hey, I have an idea. No, by educated, that means it's taking all of the information we have up to till now and doing lots of research, lots of experiments in many different labs, using many different disciplines, not just immunologically, but other disciplines to try to, and sometimes just using like public health officials to take statistics. So that's the hygiene hypothesis. So here's what we know. We know that the gut flora in the West has changed in the last few years. Yeah, normal microbiota. Could that have something to do with it? And we know that asthma rates have increased. We do know that there are a lot of pathogens, bacteria, even bacteria related to Helicobacter pylori. Yeah, the one that causes stomach ulcers. We know that that bacterium that we hate, I hate it, Helicobacter, some species secrete an anti-inflammatory substance. For whatever reason, it will stop an allergic and asthmatic reaction. We know that worms, parasitic worms, some of them will suppress an inflammatory response. Okay, so, and it's probably not just a few pathogens, but probably many. And we are, and I have this, yes, I photoshopped this man feeding the chicken pills, antibiotics. But our environment has changed, everyone. It has. So we've kind of gone from this, I love baby goats, little kids. I love all kinds of kids, to kind of something a little bit like this. Okay. This is how I grew up, by the way. We're like, no, this isn't me. So could be, got the tummy there and the cheeks, but no, not me. So here we have, again, here's the maps of autoimmune disorders. Okay, things like asthma and that sort of thing. And here's where we have the highest rates. Now, it turns out that these are the cleanest areas. Now, this is a map that shows parasitic worm infestation rates. So now, again, there's just lots of things coming into the puzzle here. This itself isn't, a smoking gun or anything, but it is highly suspicious. But here's the other thing. Do you remember? Now, this is busy. Don't look at it for now. Just listen to me. Do you remember when I told you that IgE antibodies and eosinophils are found when? When there's an allergy. When else? When there's a parasite? Yeah. So, and there's more to it. If we had time to talk about the different kinds of helper T cells and how they interact with dendritic cells, yeah, you would find that there's a lot of coincidences here. And there's a lot of scientists who are promoting the hygiene hypothesis, including Joel Weinstock from Tufts Medical Center in Boston, Massachusetts. And he's an immunologist and he's studying the body's immune response. Okay. And it's not just parasitic worms, but there's a lot of good soil bacteria, including this one, which is really nice, Lactobacillus rhamnosus. By the way, this is in a lot of probiotics. Sweet. Okay. So what am I telling you? Expose your patients to parasites? No. Not at all. Your patients are they're probably immunosuppressed. They're stressed out. No, and it wouldn't work anyway because adults, at least when it comes to adults, they've already trained their immune system or not. So, and again, your patients are probably in crisis when you see them. So, no, I'm not saying that. But maybe we need to take a look at other things. Okay, and no, we don't want to expose babies to parasites either or pathogens. No, 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 no. We don't want to do that. Maybe consider probiotics. Okay. Maybe rethink how children play. Maybe nature's okay. Go out and play a little bit in the dirt. Go out and play in the country and, play with the animals a little bit. So maybe everybody should get out and enjoy nature a little bit, collect a little soil bacteria in the gut. Okay, maybe it's not a problem. Um, some people are looking at, okay, what are the chemicals that are calming the immune system and are working as immune modulators. So these would be immune modulation chemicals. Could we find those? We're trying. We haven't found them yet. So yeah, we're working on all of this. Okay, so this is the hygiene hypothesis. If you want to look into this, you should also, there's a really freaky case study. If we had, well, maybe I'll post it. There are people out there that have given themselves hookworms on purpose because they couldn't breathe. The asthma was so bad they couldn't breathe. So they gave themselves parasitic worms called hookworms. And let me tell you, hookworms of the parasitic worms are nasty. But it worked for them. I don't know. I like breathing, but I don't like parasitic worms. So, and I could not possibly expose this little thing to something like that. So, okay, let's ask some questions. Stress reduces which of the following cells responsible for immune responses? T cells, B cells, natural killer cells, all of the above. You bet, all of the above. D. What is the hygiene hypothesis? A. Diseases caused by germs. B. The reduction of allergens at a young age will prevent asthma later in life. C. By removing germs from the environment, we may have unintentionally produced autoimmune and allergic diseases. D. By providing global immunizations, we can eradicate disease. E. By avoiding immunizations, many children avoid autoimmune diseases. And okay, disease is caused by germs is the germ theory. But okay, C, by removing germs from the environment, we have unintentionally produced autoimmune and allergic reactions, and that is the hygiene hypothesis. What is Guillain-Barré syndrome? A, an autoimmune response. B, an allergic response to pollen. C, an active bacterial infection. D, an active viral infection. E, parasitic worm larvae forming cysts in the brain. Okay, there is a condition where parasitic worm larvae do form cysts in the brain, but Guillain-Barré is an autoimmune response, and there's no active pathogen infection. There's no bacteria or viruses anymore, or probably not. Immune disorders. Immune system disorders are caused by A, genetics, B, environmental triggers, and C, all of the above. C, all of the above. So to help things out, maybe you take immune modulators, vitamin D, tryptophan, okay, your vitamin 6s. Okay. Rituximab is a drug sold under the brand name Rituxan. It's used to treat certain autoimmune diseases and types of cancer. Just looking at the name, what is the main characteristic of this drug? A chemical that targets a structure in a bacterial cell wall. B, a chemical that stimulates an immune response. C, a drug that produces the production of cytokines such as interferon. D, preformed monoclonal antibodies. E, something that produces memory cells without disease. Of course, that's D, preformed monoclonal antibodies. Remember, I said you don't have to know the drug names, but if you see MOB there, you should know these are antibodies, little heat-seeking missiles. You can attach all kinds of chemicals to it, like radioactive chemicals, anything to take out tumors, okay, and cancer cells. And something that produces memory cells without disease, what is that? Yes, a vaccine. Good. When your immune system responds to something harmless in an environment and actually causes harm, what was that? Hypersensitivity. Good. Okay. The patient is diagnosed with type 1 diabetes mellitus. What is the cause of this? A, an immunodeficiency, B, autoimmunity, C, bacterial infection, D, viral infection, E, hypersensitivity. Okay, so again, it's not an immunodeficiency. Probably it's more of an autoimmunity, so it's B. Okay, we would consider this a B. Okay. Your patient has joint pain and a rash, excuse me. Your patient has joint pain and a butterfly rash on the face. The doctor doesn't prescribe an antibiotic because they probably have what? Rheumatoid arthritis, type 1 diabetes mellitus, systemic lupus erythematosus, severe combined immunodeficiency, a viral infection. Well, of course, you would not treat with an antibiotic for any of these, but this person has systemic lupus erythematosus, which again is just the body going after the nuclei in the body. Antibodies are being made against the nuclei of the body, and you form these immune complexes, which are pretty bad. Okay, so now we're going to talk about various kinds of infectious diseases. So this is the grab bag of infectious diseases. And what I don't complete this week, of course, I will complete next week. And it breaks my heart. There are just so many things that I'd like to talk about, but there's just no time. So I'm going to give you the best hits of, I think. But hopefully after this class, you have enough information that will allow you to look things up. You have that ability. Yes, you do. And hopefully you have the foundation now to understand why antibiotics work on some things, not others. Like there are some antibiotics that work on some bacteria, but not all. The antibiotics are not going to work on the viruses, and some of the antivirals will not work on every kind of viral agent. So, yeah, and we're also going to introduce some eukaryotic pathogens, so fungal organisms, and maybe a little bit more. Okay, so here we go. We're going to start with, we're going to go through the integumentary and respiratory symptoms. This is, if you're wondering what this is smallpox. This is a good illustration to show you that now smallpox is transmitted through the respiratory tract, but clearly it causes lesions on the skin. I'm not going to do a spiel on smallpox because you're not going to be seeing it. But still, this is just to let you know that we're going to talk about skin diseases and respiratory diseases, but also know that they overlap, and a lot of these organisms that I'm going to talk about cause a lot of different problems. So just bear with me. You have to sort of put them in some kind of category. So that's what we're doing. So stay tuned. Microbes, health, and disease. Just a quick summary before we get into the little agents. Keep in mind most microorganisms are completely harmless, and we're in contact with numerous microorganisms daily, and they're not going to harm us. Some of them colonize our body surfaces, others shed with dead epithelial cells. Many are so beneficial. Remember our normal microbiota. Yes, they help to keep us immunocompetent. Yes. Okay. So they help us to produce a whole normal immune response. They not only will fight off the bad guys, but one thing I didn't mention is that they will train your immune system, as it turns out. Okay, now some microorganisms we do come in contact, of course, are pathogenic, or maybe they're potential pathogens. We will even find that some of the normal microbiota can turn on us. So, sorry, hope I didn't startle you. All right, so let's talk about pathogenicity. There are sometimes these organisms that we call the primary pathogen. It's the microbe or virus that causes disease in an otherwise healthy individual. Primary pathogens include the plague, malaria, measles, influenza, diphtheria, tetanus, tuberculosis. And with these guys, for the most part, if you come in contact with these things and you don't have any kind of memory cells against them, you're probably going to get sick. But there are also opportunistic pathogens that I want to talk about. These guys, so they're opportunistic. They cause disease only when the body's innate or adaptive defenses are not working, when you're compromised, immunocompromised, or maybe when introduced into an unusual location. That can happen too. Like they don't belong there. E. coli in the gut is okay. We don't want that inserted deep into a other body cavity. Again, opportunistic pathogens sometimes can be members of the normal microbiota, or maybe they're common in the environment, not causing trouble to most people. But if you have somebody on chemotherapy, somebody who has diabetes, somebody with HIV, okay, these are going to be problems. So we're going to talk about Candida albicans that causes yeast infections, Pseudomonas. I hope to talk about that. I don't know if I can. So you don't need to know these right away, but I did want to again differentiate between pathogen as something that generates disease. You can have a primary or an opportunistic pathogen. Virulence refers to the degree of pathogenicity. So just when I use those terms, I want you to know what I'm talking about. And again, virulence factors allows microorganisms to cause disease. So if a bacterial cell has a virulence factor, it's probably because it has a gene. Okay, keep their numbers down, reduce, reduce, reduce. Wash your hands, soap with water. I can't stress this to any of my students enough. There's a lot of things about this little quick class that you're going to forget. Please, 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 of all the things you forget, do not forget to wash your hands regularly with soap and water. Okay. So, some terms when it comes to the course of infectious diseases. When you become exposed to a pathogen, and that means it's going to generate disease. There's an incubation period. That's the time between you get the infection and the onset of symptoms. How long varies, okay? It can be anywhere from a few days for the common cold or years for hepatitis. It all is going to depend on the growth rate, how fast the organism replicates. The host might be in bad shape and it may take over quickly. Also, the infectious dose, how much do you get? I will talk about that in a little bit. There's another phase called the prodromal phase. This means that this is when it's coming on a little bit. You have vague symptoms. Illness, okay, you've got signs, you've got symptoms. So there are signs like, kind of fast heart rate, something like that going on. You've got a lot of white blood cells in your blood draw and or symptoms. You're sniffly, sneezy, coughing, got a rash, something like that. Convalescence or convalescent. This means you're in the recuperation stage, recovering from the disease. One thing I want to mention, and that's why poor Typhoid Mary is here. Typhoid Mary had Salmonella typhus. She didn't know she was a carrier. She always felt perfectly healthy and was a personal chef to many people, and her specialty was kind of a peach cobbler. And people in that were eating her food enjoyed it until they started to get violently ill and some died. And she couldn't understand, and there's a lot of serious ethical problems with the treatment of Typhoid Mary. She was Irish, she was female, and they treated her very badly. And she thought that she was that she couldn't possibly be causing the deaths of these people that she cooked for because she was perfectly fine. She didn't have any symptoms. So carriers may harbor and spread infectious agents for years without signs or symptoms, and that's what Typhoid Mary did. By the way, you too could very easily be a carrier. Most respiratory infectious organisms are contagious about 24 hours before the first real symptoms appear. So, what does that mean? You always cough and sneeze into your sleeve. You wear personal protective equipment. You wash your hands with soap and water whenever you're around your patients, okay? Especially the little ones. Okay, so let's talk about some terms here that I'm going to talk about. Some people will get a pathogen, an infection, and the body's inflammatory response is able to localize it. So we call that a localized infection. So, and sometimes they stay localized for a while and then sometimes they break away. But a localized infection is a microbe limited to a small area. So, for example, if we look down here, we have boils. Okay, created by good old Staphylococcus aureus. So just down here, okay? Now, what happens if you squeeze that boil? Like a lot of people do. Understand the keratin layer, that these proteins are tougher than the connective tissue underneath. And what'll happen is a lot of pus will get into the bloodstream. And oh, you can get something like this. So you can get a systemic infection. That means the agent is spreading throughout the body. So, not just with Staphylococcus aureus, but measles go systemic very easily. So, whenever you see the emia suffix, that means that it's in the blood. So, bacteremia, bacteria in the blood. Now, this means that the bacteria are there, they're not necessarily going to set up a disease. A lot of people squeeze a boil and they don't end up like this. So, you squeeze a boil, the bacteria is in the bloodstream, but okay, no disease. So you can have bacteremia without disease. By the way, vigorous toothbrushing gives you a lot of bacteremia. Bacteria are just streaming through the bloodstream when you brush your teeth. Toxemia, that means toxins are circulating in the bloodstream. Now that's probably not good. Viremia, viruses circulating in the bloodstream. Sepsis. Now this means that this is an acute, life-threatening inflammatory response caused by an infectious agent or agents or any kind of products in the bloodstream. So back up to Staphylococcus aureus, and it is clearly there's bacteremia, and now we have septicemia, cellulitis, and the bacteria are releasing their exotoxins, and you're getting a terrible inflammatory response. And yeah, so here's a huge battle. And of course, you draw the borderline so it can't travel beyond that. There will be more information about Staphylococcus aureus later. I wasn't sure whether to talk about them in the skin or in the GI tract. I think I'm going to do GI tract, okay? So again, remember the pathogens must overcome your defenses. Keep your barriers healthy, right? Don't smoke, exercise, take care of your skin, eat right, all of that. Reduce, reduce, reduce. Microbe numbers must be sufficient to overcome the defenses. So they have big numbers. There's something called the ID50. This is the infectious dose 50. This is the number of microbes it takes to demonstrate infection in 50% of inoculated test organisms. So if I took all of you and divided you in half, and I gave half of you a culture to drink of 10 to the eighth power bacteria. And well, let's just say, no, let's say I gave all of you 10 to the eighth bacteria, sorry. And 50% of you got sick, then that is the ID50. So 50% of you got sick when I, gave out 10 to the eighth power bacteria. So this is what happens with Vibrio cholera. They do most of these tests in laboratory animals, of course. So in the human population, they know that if a population drank or consumed 10 to the eighth Vibrio cholera cells, causes cholera, then that will cause disease or infection in 50% of that population. So that's the ID50, 10 to the eighth power. Mind you, if you took those antacids, then you don't need as many bacteria to get through. Remember, the stomach acids take a lot out. There's also the LD50. This is the virulence of the microbe or potency of the toxin, basically a lethal dose for 50% of the host. So if I gave the population a certain amount, it could be a toxin like botulism toxin and it killed 50%. That is the LD50. Okay, the number of microbes it takes to kill 50% of the inoculated test organisms. No, they don't do this in people. Just know if large numbers gain entry, the stage is probably set for disease. So there's a point where you just don't even, I mean, if you consume a lot of bacteria or organisms or toxins, you're going to get sick. Don't even bother counting. Okay, this is something else, point of irreversibility. This is the point beyond which most appropriate treatment has no impact on serious infections. This means probably you went septic. Okay, the viruses causing septicemia, bacteria causing septicemia, the bacterial toxins causing septicemia. Yeah, you won't pull through. Okay. And you'll see that a lot. Okay, so let's talk about some of the infectious diseases. And like I said before, all of these overlap into other categories, but you got to start somewhere. Okay, so here's the integumentary. I know, don't you just want to do Gucci Gucci Goo? Or worse yet, do a raspberry. I know, babies are so cute. Okay, so we're going to start off with viruses that impact the skin. Okay, so let's begin with warts. Okay, there's only one thing that causes warts, everybody. Those are the human papillomaviruses. Remember, we talked about those, or HPV. These are viruses, they're not living. You cannot treat these with your antibiotics. In fact, there's no antivirals that are going to work with these guys. Surgical interventions are necessary. So the human papillomavirus, so this is a non-envelope virus, meaning that it's going to hang around on surfaces. It's not going to die anytime soon, so you can pick this up just about anywhere. There are many types, about 40 we think, and they all cause little tumors, little warts, or something like that, okay? They all do this. Transmission very easily. Again, the little viruses have to get to the basal layer of the skin, but if you have a skin abrasion, or it doesn't have to be that severe, oh yeah. And remember, the viruses can be on inanimate objects. We call those fomites. You can touch people. There you go. Syndromes. Most of the infectious diseases that I talk about they produce certain symptoms, and with warts, of course, they're little tumors, maybe cancers. But this is the one time where it's not about inflammation. It's the way the virus actually interacts with the body. They hide, okay, from the immune response. They don't start dividing until they're pushed up to the edge, okay? So they're not detected by our surveillance teams. Okay, so syndromes. It's not about inflammation. The syndromes are basically, to start off with, benign tumors, what we call regular warts. You can have seed warts like this. If it's on your foot, we call them plantar warts because you pound them in and they go deep. So that's the only difference between a seed wart like that and a plantar's wart. So there's also genital warts, of course. Now these are, like I said, these are not pretty by any means. Cosmetically, they're awful. You have to burn these off. It's hard to do. And you have to get underneath the basal layer, so you got to go deep. And if they are forming somewhere around the cervix, it's even harder still. There are different kinds, and they are different types of viruses than the ones that cause these. So these are different. There are the HPVs that cause cancer are different strains. So those viruses infect cells in the cervix, the oral cavity, and in the anus, and will cause cervical cancer, oral cancer, and anal cancer. Diagnosis, okay, again, in women, you got to do a pap smear. So, one of the things, though, of course, we have is Gardasil. So, this is what we have. We have a vaccine that is a vaccine against cancer. Okay, it's not going to work around against the seed wart. Sorry, you got to burn those off. But the ones that cause cancer, those are the ones we're interested in, and we have a vaccine. So, yay. Again, we can just see the change, the cytopathic effects of these cells. And here's a cervix that has gone from infection to invasion and cancer. Okay, So again, these are different HPV types of viruses. They're all HPV, but they're different. Okay, whoa, what is this? Okay, ectoparasites are parasites that feed off of you from the outside. We know you're juicy on the inside, but there are some arthropods. That means you step on them, they go crunch, and they do feed on the body and they can be infectious. So I'm going to talk about those now. First of all, lice. And way back when, they used to have toys named cooties. I don't know if they still do, but what is a cootie exactly? Well, it's lice or a louse. Now, there are many different kinds, okay, but in all, lice are small wingless insects and they do suck blood through the skin. Now, the body lice are really the cooties. And the reason these are important is because they can transmit some really nasty bacterial diseases, including something called trench fever and typhus. Typhus is caused by a bacterial organism called Rickettsia prowazekii. And rickettsia, that's related actually to the Rocky Mountain spotted fever bacterium, actually. But yes, only body lice transmit this. Head lice do not transmit disease, but head lice are extremely contagious. So you got to pick off the little nits that are on the hair. Those, those are just the intermediate, like little egg casings. You've got to take those off, and you've got to use the shampoos, and you got to clean everything. Because, okay, body lice can transmit bad diseases. Head lice are just a big nuisance. Okay. Mites. Okay, now there are many different kinds of mites. A lot of these live, there's so many, and they live on the outer surfaces of plants and animals. Some of them blow around in the dust. Some can cause allergies, like dust mites, right? And can cause inflammatory responses in the upper respiratory tract. Some can trigger asthma, right? But the mites that are particularly nasty are let's talk about the ones that feed off of us, the exoparasites. So first of all, we have chiggers, which are mite larvae, and they may attach and feed on fluids within the skin cells, and they cause severe itching. Okay. Now, the other type of mite causes a condition called scabies, but again, these are both mites. Okay. This is the worst because scabies will burrow under the skin and lay eggs. And again, it is very contagious, very nasty. And it will cause kind of the red flare going up. And I think this is actually scabies and not a Chigger's reaction. But both will cause inflammation. And scabies is very infectious. So you have to be careful. It's commonly misdiagnosed, which is unfortunate. Okay, say ah. Okay, so we're going to talk about fungal organisms. They're very good at infecting the skin. And the reason is very few fungal species will go deep in the tissue. They tend to like it a little cooler, but not always. Okay, so fungal diseases. Well, here's some bread mold. Oh, no, here's a fungal disease. Okay, there we are. So fungi are eukaryotic. Mostly they are harmless, many are beneficial. Again, we use fungal organisms to make wine and beer, make bread rye. Some of them are part of your normal microbiota, actually, so they're pretty good. But there are a few that are parasites. But interestingly enough, there is not a single fungal organism that is an obligate parasite, meaning it doesn't have to be a parasite. But you're in the wrong place at the wrong time, and then you can get a disease, okay? They're extremely widespread. They're all over the place. The disease through fungal organism, the diseases occur in two ways. So number one is by mycosis and infection. But fungal organisms also produce toxins, and we call these mycotoxins. So there are two routes that can give you disease through fungi. Okay? So let's talk about mycotoxins. The first mycotoxin is called the ergot alkaloid toxin. Sometimes we call this ergot poisoning. The fungus is Claviceps purpurea, and it causes some very strange behavior. Why? Because the fungus is manufacturing psychotropic agents, basically LSD, you know, um, weird mushrooms, right? Well, some years ago in America's history, there was something called the Salem witch trials, where young women swore that they saw other women dancing naked in the moon with the devil and doing all kinds of weird things. And so, what was going on? Well, here's what we know. During that time, there was a lot of grain that was infected with claviceps purpurea, ergot. Okay. So they harvested the grain for the winter and they ate the bread. And lo and behold, crazy behavior. And that's what we think happened. By the way, cattle can eat this stuff, and sometimes they can have strange behavior too. Okay, the next kind of mycotoxin is called the aflatoxin because it comes from something called Aspergillus flavus, and this is what the fungus normally looks like. Again, this is something that cows can eat in the field, and unfortunately, it can get into the meat and dairy products. Now, the cows aren't going to like this much, but if you get a hold of the dairy products, or even directly if you get exposed to aflatoxins. You can get severe vomiting, abdominal pain, possibly jaundice, but this can even put you into a coma and kill you, and this is carcinogenic, meaning can generate cancer. This is why they condemn buildings that have had a lot of moisture. Fungal organisms love moisture on the body, on wood. And how are you going to know for sure that this is completely cleaned up? You know, I wouldn't trust it. There's remediation that can occur, meaning you can try to get rid of the black mold, but a lot of the black mold can produce mycotoxins, and it's just, I don't know, scary. Okay, so now let's talk about fungal mycosis or fungal diseases. Fungal organisms tend not to like it too warm. As I said, most fungal infections tend to be superficial, but not all of them. They are found everywhere and are very opportunistic. Oh, yes, they will move in when defenses are down. However, there are a few that will go systemic and travel to many places in the body. This is bad because oral treatment probably going to be toxic. Why? Fungal organisms are eukaryotic, and so are you. So, what's your target going to be? What is your poison going to target in their cells that won't target yours? Yeah. So, treatment is usually toxic because they are a lot like us. Now, if you have to put a topical remedy on a fungal infection, not so bad. But just know topical agents, like what we use to treat yeast infections, do not kill. They are fungistatic, meaning it could very easily come back. It's not fungicidal. So when you're thinking about, for a vaginal yeast infection, yeah, you better hope your normal microbiota kind of picks up the act a little bit. Okay. So there are two types of pathogenic fungal types. Actually, there are three, but I'm only going to just tell you the two. The first kind is the yeast kind. They look like this and they bud. And then the second type is mold, and they have a lot of filaments. One thing you should know about mold is the part you see is the part that has a lot of infectious little spores and things like that. The part under the tissue it's going to go kind of deep. This is called vegetative hyphae. Trying to get this to die is pretty hard, especially with a topical, because it will only penetrate just so far, and these go down very deep for molds. Molds tend to look a little fuzzier, but not so much in a human infection. Okay, so let's talk about some different kinds of mycosis, and I like this. It says, I'm afraid it's a severe case of tinea pedis. Here's the nurse or nurse practitioner. You could have just said athlete's foot. Tee hee. Okay, so let's talk about ringworm or tinea. The street name is ringworm. You've heard this term. I know you have. But the clinical term is tinea. So if a physician says, oh, the patient has tinea, then you think, oh, it's a fungal infection. It's ringworm, right? So you use ringworm to communicate with your patient, but tinea to communicate with your colleagues. Now, this is the superficial mycosis. Now, tinea is just the name of the disease, but the organisms are named microsporum and trichophyton and a whole bunch more, and they look a lot like this, but they all cause the condition known as tinea or ringworm. Again, it's mold, by the way. It affects a lot of mammals, dogs, cats, cows, goats, pigs, horses, and guess how I got it? I got it by playing with kittens. Yes, very easily transmitted through contact. Okay, so here we have the classic ringworm structure. So it is not a worm, it is a mold, a fungal mold. So you may or may not see a ring shape, and you might see a crusty, itchy, kind of swollen area. It might be red. It depends, but this is classic ringworm. Okay, if it appears on the head, it's called tinea capitis, scalp region. Sometimes you can use a black light if you want to see, is that really what it is? Is it fungal? What's going on here? You use a black light. In the clinic, we call it a wood lamp, and you'll find that this fungus actually fluoresces, believe it or not. In the groin, it is called tinea cruis, okay? Sometimes when you have an obese patient, they have it sort of like right under the apron, and it's very sore. It's very red and very angry. It causes a very bad inflammatory response. Just think of probably all the granulocytes there. So you have to clean very well and keep it dry. The best way is to clean gently with soap and water and then blow dry it with a blow dryer on kind of cool to medium and keep it dry and then do something topical, but keep it dry. For males, they get it especially around the scrotal area. This is a type of jock itch, although there are several types of funguses, the fungi that cause jock itch. Tinea pedis. Okay, athlete's foot. Yeah, look at the inflammation. Tinea unguum, this is under the nails. And let me tell you, if you go out for a pedicure or manicure, you better be darn sure that they are sterilizing their instruments. Why? Because if you get some of this in the nail, it'll go down into the nail bed, and you will have to take an oral antifungal. And they can't give too much to you at one point because it is toxic. They'll have to watch your liver enzymes. So remember, they are eukaryotic and so are you. So you're going to have to take an oral poison. It's more toxic against them, but it can hurt your liver. Okay? How about the common yeast infection, also known as candidiasis? What's the name of the organism that causes candidiasis? It's Candida albicans. So candidiasis got its name from Candida albicans. So this is what we call a yeast-like infection. If you ever took my micro class, actually we call it a little bit yeast, little bit fungal. It's a dimorphic, but I'm okay with you learning it as a yeast. This is very opportunistic and very, well, it is commonly seen in very young patients, immunosuppressed patients, patients who have taken antibiotics and gotten rid of their normal microbiota. How do you transmit it? It's part of your normal microbiota. They just don't get out of hand because the other guys are there. So they are in your oral cavity, in your anus, in the vaginal area, all around those areas and throughout your skin in many areas. They prefer it moist, but yeah, they're all over. So what happens is again, they're mixed up with your normal microbiota. Hopefully your normal microbiota is in place and everything is in place to keep them at bay. But if things go out of whack, remember that's dysbiosis, then yes, then you're going to get candidiasis. So, example syndromes of candidiasis, vaginal candidiasis, also known as the vaginal yeast infection. So, women with vaginal candidiasis will get sort of a slick, buttery kind of of consistency in a vaginal discharge, and it will smell like alcohol. Why? Because yeast are fermenters. So whether they're making beer and wine, which is a different species, or the one that is giving you a candidiasis, okay? Again, guys can get their version called jock itch. There's also oral candidiasis, common in children, common in patients who are immunosuppressed. So this is oral candidiasis or thrush. Now, again, a lot of patients that haven't developed their immune system yet, like children or patients who are undergoing chemotherapy or are immunodeficient for whatever reason, will get candidiasis. Will get this. Children get it all the time. Okay, and it's different than the pus pockets made in group A strep. So here we have again, this is oral candidiasis, and this is where you would see this in a vaginal yeast infection. So how do we not get this? Well, cleanliness, wiping from front to back, keeping your normal microbiota in health. And when you take an antibiotic, get some probiotics going on there. Okay. I wish I had time for this. If you've ever seen somebody who is lighter skin that has dark blotches or dark skin with white blotches and you wondered what that was, that is actually a superficial mycosis caused by an organism called Malassezia furfur, and the disease is called pityriasis. I know, aren't you glad you didn't have to know this? But it's all cutaneous. It can cause some problems, some more severe problems in some individuals. But interestingly enough, when the fungi grow, they can cause too much of a pigment because they will produce melanin, right? Just like our own melanin. Sometimes they will release a type of acid that will actually bleach out the skin and cause hypopigmentation. So, FYI only. All right, something else. Okay, so this one crosses the edge. This is something called sporotrichosis. The street name would be rose pickers or rose handlers disease. This one starts out as sort of a superficial, but it can go systemic. The organism's name is Sporothrix schenkii, which again is why it's called sporotrichosis. I'm only going to have you guys know sporotrichosis. You don't have to know the species name. But again, this is a yeast-like organism, not a mold. Symptoms, well, let's just put it this way. It's called rose handlers because people who get cuts, a lot of times the spores and the molds just are everywhere, and the spores can be on the thorn, and it breaches your first line of defense, your skin. And they start to divide and grow in underneath the tissue. And again, it can be rather localized, but it can, and be just a bump on the hand, but it can grow to produce a very large lesion. So let me show you some pictures. Oh, shucky darn, sorry. So this shows where it's causing a really nasty lesion. It almost looks like the body was trying to wall it off, but it looks like it's escaping. And it will, and it goes systemic, and it goes along the lymph nodes and can cause tracts like this. A lot of fungal organisms will do this. It's just like connect the dots. What is going on here? And it's just in a line. And again, it's along the lymphatic system, along the lymph nodes. Now, this can grow in the lungs, unfortunately, causing pain in the chest, shortness of breath, and can be life-threatening, as you can imagine. Okay, another mycosis. This one is histoplasmosis. It's also systemic. This one really blurs the line between skin and respiratory, but I thought I'm just going to get all the mycosis done in one shot, okay? So bear with me. This is called histoplasmosis. You might have seen a patient with histoplasmosis if they were, again, immunosuppressed, if they were on chemotherapy. It's called histoplasmosis because it's caused by Histoplasma capsulata. Here it is. This is a yeast-like organism. Okay. And it is very slow to invade, and it doesn't tend to bother us. You and I could hopefully go walking up and down this riverbank And in the air, there's going to be lots of dust particles and lots of different fungal spores in there. But it wouldn't be a problem even if it was Histoplasma capsulatum. But for your immunosuppressed patient, this could be life-threatening. Okay? So you can also get this, your farmers kicking up, as they're plowing, they're inhaling, what's in the soil. So they can get histoplasmosis very easily as well as other fungal organisms. This is why when you have patients on chemotherapy, especially the farmers, you're going to have to tell them to wear their mask. They're not going to want to, but you're going to have to tell them what can happen. Because I'll tell you what, once this thing goes systemic, this is bad. So it causes a lung disease, fever, chills, chest pain, wheezing, shortness of breath. It does cause a rash as well, usually. Okay. So we're still kind of keeping on the skin diseases. Transmission, like I said, spores in the soil along riverbanks and all other places. Little FYI, this is very common in older and sick animals. It is the most common fungal disease diagnosed in dogs, by the way. Don't need to know that. Here's another one you can get and your farmers need to look out for when they're breathing in the spores. This is Cryptococcus neoformans. This is a real yeast, and by golly, it has a capsule, which means this is really bad because the immune system is not really going to see this. This one is very common. This fungal disease is associated with wild birds and pigeon droppings. So if you have a patient that is coming in and they keep birds, and they have a terrible chest pains and coughing and all of that, okay, that might be it. So it is a lung disease, but this one also can give you blurred vision, confusion, fever, chest pain, especially in the breastbone, a non-productive cough, possibly with bloody sputum. Here's a chest x-ray, and you can see there's so much inflammation, not a lot of area to breathe. Also, a rash does appear with this one as well, interestingly enough. So this is bad. And again, these are systemic. So you're going to have to give the patient a poison that is, again, it's going after a eukaryotic cell. And these are eukaryotic cells, and unfortunately, you are made of eukaryotic cells. So these drugs can be extremely toxic, but understand something. These patients are very critical right now. And you know what? Give them the drugs, whatever they need. And, you're just going to have to deal with the liver and the kidneys later on. Really quick, there is something called farmer's lung, which could be caused by all the things I've mentioned, and then some. Lots of fungi can get into the lungs and cause farmer's lung. But the biggest cause is Aspergillus. So it's common in the grain. Here it is growing. Here it is under a microscope. So it is a mold, and it's inhaled, found in decaying vegetation and grain bins around this area. The syndrome, it's a terrible inflammatory disease of the lungs. And of course, penicillin won't do the slightest against it because penicillin works against what? Bacterial cell wall PBPs. Yeah. So does a fungus cell have a bacterial cell wall peptidoglycan? No, it won't work. So again, this is going to affect your immunosuppressed patients, your diabetics, your cancer patients, and particularly people who want to go out in the garden or farmers who don't want to stop. Okay. Here's the really bad part about this. This can go into the brain. Most of these organisms, again, keep in mind that none of them have to be pathogens, but a few of them really can go to town and cause lethal results. So here, this is an autopsy. As you can tell the necrotic black areas and the bleeding out of the brain. So this is bad. Okay, what type of agent is this? A worm, a virus, a mold, a yeast, or a bacterium? It is ringworm. Nah, it's a mold. Okay. These chemicals come from fungi. Some are carcinogenic and some are psychotropic, like they make LSD, or it is LSD. So is this a mycosis, a mycotoxin, mycology, or candidiasis? Mycotoxin, of course. Okay. Which of the following is another name for vaginal yeast infection? Cryptococcosis, farmer's lung, mycotoxin, candidiasis, tinea, sporotrichosis. Of course, it's vaginal candidiasis. Good. D. How is candidiasis transmitted? Through respiratory particles, fecal, oral. It is part of the normal microbiota, casual contact, a cut or abrasion on the skin. C, it's part of the normal microbiota. This, as well as many of these things, are opportunistic. They're there already. You just messed up your normal microbiota and or something happened, okay? So they're there already. But it can also be fecal oral, just so you know. Which is true concerning fungal organisms and mycosis? Okay, so A, they are very strong, virulent pathogens even in healthy humans. B, they tend to be opportunistic. C, they prefer warm temperatures. D, they are not common in the environment. B, they tend to be opportunistic. Not always, but usually. So again, normally they're not going to attack healthy, happy humans. They tend not to like the warmer areas. They like it a little cooler. They like it moist too. And they are extremely common in the environment. Okay, what is the clinical term for ringworm? Toxoplasmosis, tinea, tania, cryptococcosis, sporotrichosis. That would be tinea. Tania is actually a parasitic worm. And cryptococcosis, no, that causes that's not it. Okay. And sporotrichosis would be what? Rose picker's disease, right? Okay. Which of the following is most likely to cause an opportunistic but systemic respiratory infection? Candidiasis, Candida albicans, tinea, histoplasmosis. Okay, so candidiasis and Candida albicans, pretty much the same thing. No, these guys are not going to be systemic, and neither is tinea. So, because that's ringworm. So histoplasmosis, D. Respiratory diseases. Yay, there are so many. I'm just going to have to do the best I can, you guys. But with these guys, think inflammation. All right. So first will be the viruses, then we'll move to the bacteria. First of all, cold viruses. There are two. One of the cold viruses is known as the adenovirus, and that causes spring fever, or it's a spring fever virus. This is a non-envelope virus, so it can hang out on all kinds of surfaces, doesn't easily die. Transmission through respiratory droplets and fecal oral transmission as well. Syndrome is spring fever virus. Now, you probably wondered, was that really a thing? How did that get its name? Is it just because we get it because we want to go outdoors and we're stuck inside and we get infectious diseases? Sometimes. But no, this happened because actually it was named after boot camp and spring training. So you put a lot of usually young men in tight quarters. They're stressed. Their hygiene is bad. They're coughing, they're sneezing, they're touching everything. And remember, it's not only respiratory droplets, but also fecal oral. So it's just a wonderful place for a virus to hang out, and it'll go all the way through the barracks and cause spring fever. And there you go. Okay, so symptoms, cold with respiratory symptoms. It can cause diarrhea, but also if you rub it into your eye, it can cause a viral pink eye, also known as conjunctivitis. So conjunctivitis is pink eye. Complications, this one can go up and cause viral encephalitis. And there's nothing you can really do. Well, there are a few drugs, antivirals for this one. I take it back. Rhinovirus is the common cold virus. There are hundreds of these, and they mutate so very rapidly because they're RNA viruses. So yeah, even when you get memory cells against one, they mutate and they change, and it just doesn't work anymore. So we'll never get a vaccine against that. But these are non-envelope viruses. Again, they can hold out on all kinds of surfaces, all respiratory, so it's not oral fecal. The syndrome is the common cold. So think rhino, rhinoceros, nose, common cold. Complications, really not a lot that we know of. It could really bring down maybe your defenses. You might get a secondary infection, something else can move in. But, for the most part, we say it's self-limiting and you should be okay. Oh, there it is. Sorry, there's the pink eye or conjunctivitis. The conjunctivitis is just an inflammatory response of the conjunctiva. It can be caused by many different viruses and amoeba and bacteria. Okay, all right. Influenza viruses. We had a little taste of influenza earlier. Let's go into this. So, influenza viruses, these are enveloped, but that means they don't last long on counters, but they're in the air. So, somebody sneezes behind you, achoo, and then you got the blow by, right? Okay, so sneeze into your sleep. Influenza is not the stomach flu. Stomach flu is a misnomer, although it is true, that some children will get influenza and get GI symptoms, and possibly adults in very violent cases, but this is respiratory. Respiratory, okay? Respiratory droplets. There are three types, three genera. And you know this because you see this on the vaccines you give your patients. You'll see influenza A, B, and C. What are the differences, you ask? I will tell you. Influenza A, this is found in humans, but also pigs, birds, and horses. I'm going to come back to that. Influenza B and C is only in humans. Okay. Now, check out the H and the N proteins here. So here we go. We've got hemagglutinin, which is a little protein spike, and we've got neuraminidase, which is another protein. So, hey, is that where H1N1 comes from? H in hemagglutinin, N in neuraminidase? Yeah. Each type of virus, each class has different kinds of H's and N's, and that's how we classify them. Okay, let's move back to influenza A. Influenza A, the reason I have this highlighted is because it does jump ship. You can get this from pigs, birds, and horses. So humans get it from animals, and this causes emerging diseases. Those are the scariest. That would be emerging diseases include, Ebola and HIV and SARS and lots of other ones. So anything that jumps from an animal to a human is bad. And influenza A is one of those that can do that. Doesn't always, but it can. So again, influenza A, normally the typical kinds are just going to affect the upper and lower respiratory tract, maybe the GI tract, but you get your inflammation. Okay? All right, so transmitted again, this is a respiratory disease. You are contagious a day before symptoms. Dang. So during incubation, you're contagious. Symptoms, like I said, it is a respiratory disease. It's not the stomach flu. Fever, usually high, but I've had influenza A and didn't have any fever. And my doctor was so smug to let me know that I had influenza because she knows what I does. She knows what I does. She knows what I do for a living. And she's not an infectious MD, infectious diseases MD. So she was right and I was wrong and I was hot and she knew it and she loved it. I love my doctor, by the way. Headache though, extreme tiredness, a dry cough, sore throat, runny nose and or stuffy, muscle aches. Viruses are very good at causing muscle aches. Like I said, stomach symptoms such as nauseousness, vomiting, and diarrhea can be there, but it's more common in children. This is more respiratory. And again, we have a vaccine, but because this guy mutates all the time, we need a new vaccine every year. We have to guess which viruses are coming a whole year ahead of time. And then usually we use a combination of influenza A's, B's, and C's, depending on what we see coming. So the antiviral, that we have is the neuraminidase inhibitors, but what did we learn about those? So Tamiflu, you only have to know about Tamiflu, which is a neuraminidase inhibitor. It's under a group of drugs known as oseltamivir. So what you need to remember is Tamiflu only works within the first 24 hours after onset of symptoms. This is usually true of all of the neuraminidase inhibitors. Neuraminidase inhibitors, what are those? Okay, remember, here. Neuraminidase, that guy, right? Okay, keeps the virus from escaping. But it only works again if you catch it. The problem is the first 24 hours you think you have like another cold, you have a cold. You don't think it's influenza, so it's going to be too late. And Tamiflu, yeah, it can cause neuropsychiatric events, especially in your elderly and in the very ill people. So I'm not a fan of Tamiflu. Okay, seasonal. When you get seasonal influenza, it's probably B or C, and it goes from human to human to human. We're sort of kind of evolved to handle B and C because they're only within humans. No big surprises, nothing that's going to cause a big cytokine storm. So about 5 to 20% of the population gets just the regular seasonal flu. Approximately 200,000 people are hospitalized from influenza complications each year because this brings down your immune response. So you are susceptible to all kinds of things. Okay. By the way, again, 36,000 people die from the flu every year. And that's an old statistic, but I couldn't find the updated CDC one. Sorry. Funding, right? Pandemics are usually from influenza A because it causes a cytokine storm. What are cytokines? Those are all of the battle signals, right? All the white blood cells talking to everybody, talking to parts in the body. You get a cytokine storm, and that can produce hypoxia. So you can see this person has severe cyanosis, septic shock, heart failure, actually multi organ failure. This is how bad this can be. Okay, so this is actually an illustration from, well, it actually is supposed to refer to something that happened in 1918. What happened in 1918? We had an influenza pandemic. Which influenza would it have been? A, B, or C? A is correct. So, yes, this was one of the, well, this was without a doubt the worst um, case scenario of influenza that we had in human recorded history. So, okay, so this is influenza A, but this is a pandemic. What's a pandemic? It means that it went worldwide, it went global. Now, epidemic means in a certain area. We have normal flu outbreaks, epidemics, but pandemic is worldwide. HIV is currently a pandemic. Okay, so we called this 1918 flu the Spanish flu. And the symptoms again, cyanosis, severe obstruction of lungs, coughing up blood, hemorrhaging, suffocation, and death. You can see there weren't enough, there's no hospital beds. And these are the lucky ones. Most people are outside. This is bad. By the way, it's called the Spanish flu because we were fighting World War I and nobody wanted to let out the facts that there was influenza going around our troops. And so we sent the troops in small confined ships overseas, and it spread the influenza all throughout Europe. But we were fighting World War I, so we didn't want to own up to it. Nobody did, except for the Spaniards who went, hey, this is flu. Spanish flu? Spaniards. No, this started, guess where? Okay, yeah, United States, but no, in Kansas. It started in Kansas, where we had some training going on with our troops. Okay, so here are just some of the pandemics. You can always remember influenza A is the pain in the, okay, this is the bad one. So Spanish flu, H1N1, hemagglutinin neuraminidase. This is 1918 to 1919, caused about 675,000 US deaths and more. This is just from influenza. It doesn't tell you what they died of because they went back to work too early and got something else, because this does suppress the immune response. There were 50 million deaths worldwide, again, just to influenza, not to secondary infections. In the 50s, we had the Asian flu. We got 70,000 US deaths, 1 to 2 million deaths worldwide. Hong Kong, and notice how the H's and the N's change. We saw a little less, 35,000 cases of deaths in the U.S., 700,000 worldwide. And then, of course, we worry about the bird flu. We did have some swine flu coming through that was a shock, and that was an H1N1. The swine flu that we got, it freaked people out in 2010 because it came when it wasn't during flu season. And the Obama administration said, we're going to declare this a pandemic. And you know what? I'm perfectly all right with this because with education and people saying flu, we haven't had another Spanish pandemic. Yay. Okay. So again, we don't want this. Okay. But yeah, it can jump ship from animals to humans, and this is what happens. I just wanted to talk about some other respiratory viral diseases that you remember, right? Measles virus or rubeola virus, all respiratory, extremely contagious, communicable like chickenpox. You're going to find out contagious a day or even two before symptoms. High fever, sneezing, runny nose, high-pitched cough, miserable, inconsolable children, and the rash from the hairline down, in case you forgot. Remember, though, this isn't the thing that scares you. This will bring down your immune response, and the complications can be very serious, and you can get secondary infections, and that can be lethal. Okay. And of course, we have the measles, mumps, and rubella vaccine. How about mumps? Also viral, also respiratory. Mumps, you get the swelling of the salivary glands and other glands too. That's where the virus tends to enter and it invades those cells there. You get sneezing and coughing and fever and headache and sore throat. The side effects are deafness. They used to think that this caused sterility in boys, possibly in women, young girls, but that was overstated, really. But it's still not good. It can cause mastitis in the testes, ovaries, and breast. But pancreatitis is bad. Meningitis and encephalitis is bad. So meningitis is the covering of the brain. Encephalitis means it's in the brain. It can cause also a spontaneous abortion in in a pregnancy. So this is why we have, oh yes, the MMR vaccine. Measles, mumps, haven't done rubella yet. The vaccine is 95% effective. How about rubella? Viral, respiratory. Okay. Symptoms, mild fever. Okay. Runny nose, but inflamed eyes, swollen joints, red rash, and there you go. But okay, it doesn't seem like a big deal, but the problem is in a pregnant women. They get congenital rubella syndrome linked to many diseases and spontaneous abortion. Actually, in a pregnant woman, this happens in about 20% of the cases. But we have an MMR vaccine. Okay. Let's move from viruses to bacterial respiratory diseases. There are so many. I'm just going to talk about a few of these. So let's talk about tuberculosis. This is the biggie. This is by far the biggie. Tuberculosis is found worldwide. It is caused by a bacterium known as Mycobacterium tuberculosis, but you can also get a form from cattle, from especially dairy cattle, called Mycobacterium bovis. The significance, again, you don't need to know the statistics, but no, it's important. Historically, tuberculosis has caused about 1/7 of all the deaths in adults in human history that we know of. Today, we still see about 1 billion infected worldwide. That's 20% of the Earth's population, but we still see about 3 million deaths per year. It is on the rise because it's very resistant. It's a resistant bacterium. It mutates and is tough. And also compliance is hard. We'll talk about that. It is closely associated with immunodeficiencies, especially with AIDS. Transmission, it is through respiratory droplet nuclei. What is that? Those are the little tiny particles that have moisture in them that you do not see. Okay? You can also get Mycobacterium bovis from unpasteurized dairy. And what can happen is you can get a primary lesion. and in this case, usually it's through the respiratory droplet nuclei. The first lesion is called a tubercle. It is invisible, you can't see it, but it can hide in there. Usually it's inside macrophages and it's hiding in the macrophages, and it will even form a like a calcium walled off little area that we'll talk about later on. Now, it can break out of there for reasons we do not understand and become active. So, the primary complex means that it breaks out of the tubercle, gets into the lymph nodes, and causes lesions there, causing again a secondary lesion. It can go out of the lungs, out of the lymph nodes, and go throughout the whole body and cause something called miliary tuberculosis. Now, you're looking at this going, holy smoke, look at the little dots in here. It actually has the consistency, a little bit of little bits of cottage cheese, but this is actually in an alpaca. These are not human lungs, but just to show you miliary, and it's named after millet seeds. But Eleanor Roosevelt had miliary tuberculosis and died of it. So it goes throughout the whole body and affects many organs. So again, this is actually Mycobacterium bovis from an alpaca lung, but same thing can happen with just regular Mycobacterium tuberculosis once it breaks out of the primary complex and goes traveling. So who is most affected in the U.S.? The homeless, the elderly, malnourished people, alcoholic, poor males, minorities, immigrants, prison populations, and Native Americans. So if you work in helping out at the Francis House or Open Door or the Salvation Army Adult Rehab Center, you'll get a lot of people testing positive for TB. That does not mean they have active TB. Okay, it's probably in a primary type of tubercle lesion. Okay. By the way, this is a prison population, not in the United States. This is in Russia. The Soviet Union is really, they are known for tuberculosis and resistant forms. Okay, so prison conditions and all. So let's just talk about the disease course. Like I said, the bacteria are phagocytized by white blood cell macrophages on purpose, but they don't get digested. They enter, but they're not digested. The inflammatory response produces the hard nodules called the tubercles. And here you can see kind of the tubercles forming here. And it could be that the body walled it off and that's the end of it. And this happens in some people. However, the bacteria can remain alive and dormant for years and years and years and years and years. My aunts found out that they were TB positive in their 60s, I believe. Okay, one of the ways to test for this is the tuberculin or Mantoux test. So what is this exactly? So the Mantoux test gives you something called purified protein derivative, PPD. What's it? So these are bits and pieces of the actual bacterial cell, and they've injected it into the skin. Now, what are they waiting for? Well, you see, if you have never been exposed to Mycobacterium tuberculosis, you'll get a little bit of a reaction, a little inflammatory response, but not big. If you have been exposed several times before, you've made enough memory cells, you're going to probably get quite the cell-mediated delayed hypersensitivity response, and you'll get a very big type of what's called induration. So you don't need to memorize any of these numbers, but of course 2 to 3 days is when you take the reading. So 0 to 5 millimeters is negative, 5 to 9 intermediate, 10 is positive. You and your colleagues are going to see a lot of false positives. Why? Well, you're injecting real pieces of the bacterial organism into the tissue. Eventually, your body could say, hey, we have a real infection, and you could mount a real serious hypersensitivity and get something in the intermediate or the positive range. So don't freak out, and you also have to tell your patients this. If they've had a lot of manto tuberculin tests, or whatever, it could be they get a false positive. So do not freak out. Okay, the next step is to get a chest x-ray. So how do you confirm a case of TB? Well, x-rays, yes, but there are other clinical symptoms or clinical signs and tests to do. I just wanted to show you all the little nuclei. Some of these are big droplets, but the droplet nuclei are the invisible ones. They can travel yards, feet, okay, uh, and so forth. Mycobacterium tuberculosis spreading throughout the blood to the bone, kidneys, and brain is called primary lesions, primary complex lesions, tertiary lesions, or miliary tuberculosis, also known as secondary tuberculosis. Okay, miliary. Yes, if I had that on a test, it would be miliary. Okay, what is a TB primary lesion? When Mycobacterium tuberculosis is walled off by the lungs, when Mycobacterium tuberculosis is in the lymph nodes, when Mycobacterium tuberculosis is found in the kidneys and brain, when Mycobacterium tuberculosis is found in the bone, when the lesion is detectable by X-ray. And of course, that means that the Mycobacterium tuberculosis has been walled off in the lungs. That's the primary lesion. Okay, so how about something else, you ask? Okay. You get a vaccine for something called Hib. What is Hib? Hib is Haemophilus influenza B, okay? Also known as H flu. Okay, I'm confused. Is this the influenza virus or not? I don't get it. No. Okay, little history. While the 1918 Spanish flu was going on, there were scientists everywhere trying very hard to figure out what was going on. In a lot of the patients who had real influenza, they had this bacterium growing in their nasopharynx, not realizing this organism is very common and and it's really going to take over if you're sick and have influenza. So they thought this was it, and they then pronounced this as Haemophilus influenza, and they never changed the name, but it's bacterial. So yes, you can treat this with antibiotics, sometimes called H flu. So this is a gram-negative, it's pink, gram-negative bacterium. Some of these can live in the nasopharynx and never cause disease and never go deep tissue. Those would be the ones that forgot how to make a capsule. It's probably genetic, they forgot. But the ones that make the capsules are the nasty ones. Transmission, very common in respiratory tracts. You cough, you sneeze, there you go. The disease itself, well, so if you have a population of children who have not been vaccinated, and we did have that before the Hib vaccine, 1 in 200 children would develop the invasive form before age of 5. Of those children, 20% would develop meningitis, so it would get in and cause an inflammation around the meninges, which is the covering of the brain. It can cause joint infection, in some cases even paralysis. But for these children, it is responsible for nearly all cases of epiglottitis. Sorry, the epiglottis is swollen back there. So this can produce swelling of the airways and even suffocation. But golly, we do have a Hib vaccine, HIB, Hib, and it is 97% effective, at least in the US. So why isn't it 100%? Because your children are, every child is a little different, right? Right. Okay, how about Streptococcus pneumoniae? This is a misnomer. This guy is really not streptococcal, it's a diplococcus, but it is a gram-positive. Sometimes we call this pneumococcus, and we say that it causes pneumococcal pneumonia, but this is Streptococcus pneumoniae. Morphology, gram-positive, purple, gram-positive bacterium with a capsule. Oh dear. Yeah, oh dear is right. Some people have this in their respiratory tracts. In fact, a lot of people do, but it doesn't cause trouble. But it can. It is very common in respiratory tracts. Again, disease. It is the leading infectious disease cause of death and illness worldwide. It was politically incorrect in the day, and nobody says this anymore, and that's good. They used to call this the old man's friend, meaning that most of your patients who were failing because they had so many health conditions, like cancers or diabetes or whatever, they usually died of pneumonia, and that is still true. And typically, it's going to be streptococcus pneumonia, and that's what they die of. So they called it the old man's friend, kind of putting an end to the other suffering, I guess. But yeah, we don't say that anymore, or at least not outwardly. Yeah. It's kind of not very happy, but it's the truth. We see approximately 500,000 cases, lung cases per year of streptococcus pneumonia. The elderly and the immunosuppressed are going to be hit the hardest. So this again shows you the streptococcus, okay, pneumococcus, because they're really not strepto, they're diplo. But look at the inflammation in the inflamed lung. This is an autopsy. Bad, bad, bad. Of course, we have a vaccine. It's the pneumococcal vaccine. This is just to show you some of the most common pathogens, bacterial pathogens found in a hospital to cause respiratory diseases. So Streptococcus pneumoniae is always number one. Mycoplasma pneumonia causes walking pneumonia, and I don't have the ability to talk about that one. We just don't have time. But Haemophilus influenza is there, and there are other gram-negative bacilli like something called Pseudomonas aeruginosa, Klebsiella pneumonia, Staph aureus also, very much so. So this just shows you, what's most common in hospitals. Okay, we're done. Yet another. We're almost done. But before we go, little Thanksgiving greeting. Have a good Thanksgiving, however you celebrate it. For the sports fans or the turkey fans, I thought this was funny. This is from Irma Bombach. She's my generation. Your grandparents will know who she is. Probably parents too. It says Thanksgiving dinners take 18 hours to prepare. They are consumed in 12 minutes. Half times take 12 minutes. This is not a coincidence. You all have a really great week. Let me know if you have any questions at all. Okay. I'm here to help, love to help. And happy Thanksgiving.